So today we're going to be doing this integral. It's a pretty messy integral, and there's like a couple of ways to do it, but I think by far the easiest way is to use this little trick. It's actually easier to solve what this integral is equal to, and then divide it by 2. And so there's a little trick you can use here. So this integral is also equal to the integral of the square root of the tangent of x minus the square root of the cotangent of x dx plus the integral tangent x plus the square root of the cotangent of x . And so hopefully you can kind of look at these. So if you just add up the tangent of x and the tangent of x, it's going to be the integral of 2 times the square root of tangent of x. And so basically that's what we're doing here, except we're just adding on and taking off. So however much area this adds under the curve, or however you want to imagine it, or how much that takes off, this is going to put it back. So this is going to be equal to 2 times the square root of the tangent of x. And it's going to be pretty useful in creating an integral that is a lot easier to solve, because we can solve each of these in parts and then divide it by 2, and that's what we're going to be doing in this video. Sweet. All right, so let's get started with this integral up here. The first thing we want to kind of take a look back is, we've got tangent of x. Tangent of x can be represented as the sine of x over the cosine of x, and then we've got cotangent of x, which is also can be represented as the cosine of x over the sine of x. With square roots, we also know this other property that if something, we can break apart the square root, it plays nice with division. So we're going to split the square root up to the top and bottom, and we're also going to separate those tangents and cotangents. So that's going to look like this. And so that's going to look like that. The next part, what we're going to do here is, if we get a common denominator, it's going to look pretty nice in the numerator, I think, for our next step of this equation. So let's go about getting a common denominator. So this one, we need to multiply by the denominator over here. So the square root of the sine of x times the square root of the sine of x is going to be the sine of x minus the cosine of x times the square root times the square root, which is going to be cosine of x. And that's all going to be over the square root of the sine of x times the cosine of x. And all of that is going to be dx. That's kind of our next step. So for here, once we're here, it's starting to look a little more doable. The weird part that is going to be hard to figure out if you didn't know is going to be the u sub. And so for this u sub, we're going to do something a little bit trickier. We're going to make the u equal to negative sine of x plus the cosine of x. Yeah. And so when we do this, if we distribute that out, that's going to be negative sine of x, negative cosine of x. And when we take the derivative of negative sine, it becomes negative cosine. And when we take the derivative of negative cosine, it becomes positive sine. And so really what we're doing with this u sub is we're trying to think of something that its derivative takes out the numerator. So that's pretty much what this one does. The du here is equal to the sine of x minus the cosine of x dx. And that's what you're going to get if you take the derivative of that. So the next part that's kind of tricky about this is we're going to need to go and rearrange these to be this. And it's going to seem weird how you get there, but you can mess with these and make that. The first thing we're going to want to do is, I think we're going to want to square both sides. And so when we square both sides, we're going to have u squared is going to be equal to the sine squared of x plus 2 sine of x cosine of x plus cosine squared of x. And so that's what happens when you square both sides of the original equation, because they're all negative, so yeah, they're all going to be positive. This right here, this is also going to be equal to the, like, here's a little thought bubble. That's also going to be equal to the sine of 2x, which isn't going to be super useful for this one, but it's something to keep in mind. Might have been useful. But here we see this one and this one. Those are going to add up to be 1, so let's make that. So u squared is equal to 1 plus 2 sine of x cosine of x. This is starting to look good. As you can see now, instead of adding a cosine and a sine, we've got them multiplied together, and that's one step closer to down here is what we're trying to create now. So let's subtract the 1 to get it on this side. And so we get u squared, let's write this a bit bigger, u squared minus 1 is equal to 2 sine of x cosine of x. Okay. Now we're going to want to divide it by 2. So let's get that over there. Let's just do that with this. So now we divided by 2 and we got it over there. So now we want to flip. So let's get 2, let's flip everything. 2 over u squared minus 1 is going to be equal to 1 over the sine of x cosine of x. And then if we take the square root of everything, we're going to get root 2 over u squared minus 1, got the square root of that as well, is equal to 1 over the square root of the sine of x times the cosine of x, which, woohoo, it is over there. So now we have got all the components that we can put back together and fill our u sub into this integral. So let's do that. So we've got the integral. The du is going to take care of the numerator. So we're just going to have to bring in the u. So we're going to get root 2 over, so since we got rid of that, and now we need to bring in this one. Since this is equal to that, we're going to bring this in. So the square root of u squared minus 1 du. And so that's the next part of our integral. And this, you probably are starting to see, is now going to be a trig sub. We've got a u under here, but first I think let's bring that out front. So the integral of root 2 of 1 over the square root of u squared minus 1 du. All right, so let's bring this up over here. This integral, we're going to bring it up right here. Root 2 of 1 over the square root of u squared minus 1 du. And And so the next part here is we're going to do the trig sub. So this trig sub is going to be something squared minus 1. So we're looking at a secant u sub. So u is going to be equal to the secant of theta. And so the du is equal to secant of theta times the tangent of theta d theta. And so when we plug that in, we've got to go, the du is going to come on the top, so secant of theta tangent of theta over u is going to be secant, so we're going to have secant squared minus 1, which is also equal to the, so it's going to be secant squared of theta minus 1, which is also equal to the tangent of theta squared. So we're going to plug that in there and then take the square root. So we're just going to get tangent of theta on the bottom, d theta. And so here we can cancel those tangents out. And so we're just going to need to, there's a root 2 here still. So root 2 times the integral of the secant of theta d theta. And we're starting to come to the end of this one now. To integrate secant of theta, that's going to be equal to, you got to know this one or just look it up. I think it's just a pretty simple one. It's the natural log of secant of theta plus the tangent of theta, I believe. Yep. Plus c. And so that's what we get when we integrate this. And so now we need to replace this back into its original form. So we're going to need to create the triangle for our trig sub so we can figure out what those are equal to. So this one's going to be, u, and then this one's the square root of u squared minus 1, and this one's going to be 1. And so when we get secant of theta is going to be equal to u, and then the tangent of theta is going to be equal to the square root of u squared minus 1, which is going to be equal, I'm going to do cramp it. So remember, our u sub goes all the way back to here, and so we need to plug that u sub back into here so we can get it back in terms of x, because that's what they gave it to over there, and we're deriving it in terms of x. So we're going to get, let me erase this c so I have a little bit of room to work over here. So we're going to get the square root of the negative sine of x minus the cosine of x squared minus 1, which is going to equal the square root of the sine of 2x. So here we're going to get sine squared plus 2 sine of x minus, or plus the 2 sine of x cosine of x plus cosine squared of x minus 1. So we're going to get 1 and then minus 1. So those will cancel out. And so we'll only be left with that 2 sine of cosine, or 2 sine of x cosine of x. And then that'll be over here. And so we are done integrating. So root 2 ln of the natural log of the secant. So secant is equal to u, which is negative sine of x minus the cosine of x plus the square root of the sine of 2x plus c. And so basically, this is going to be the first half of what the square root of the tangent of x is going to equal. Okay, so part 2 of the equation is going to be the exact same, except for we're going to have a plus instead of a minus. So we're going to go through it pretty much the exact same up until this part. So we're going to separate them out into sine over cosine, and then we're going to split the square root sign and separate those out as well, and we're going to do that to both of them. And then down here we're going to get a common denominator, and so we're going to multiply that side and then multiply that side, and so we're going to get sine of x plus cosine of x over that. And so the only thing that's going to be a bit different is the u sub is going to work out a little differently, and that'll have some consequences down the road, but we'll do that when we get there. So same idea, we want to create a u sub where the derivative of the u is going to take care of our numerator. So for this one, I think we're going to do the sine of x cosine of x, and then the derivative of sine is cosine and sine, so du is going to be equal to the sine of x plus cosine of x. And so the u sub, now we're going to start rearranging it to try and create this, the denominator, like we did last time. And so we're going to get, we're going to do the same thing. We're going to square both sides. So we're going to get u squared is going to be equal to the sine squared of x minus 2 sine of x cosine of x plus the cosine of x squared. So this and this is going to equal 1. So let's add those together and then subtract it to the other side. And so u squared minus 1 is going to be equal to negative 2 sine of x, the cosine of x. Now we want to get this negative over here, so let's multiply both sides by negative 1. So we're going to get 1 minus u squared is equal to 2 sine of x cosine of x, and then we're going to divide it by 2. And so we're going to get 1 minus u squared over 2 is going to be equal to the sine of x times the cosine of x. And then so we're going to flip them both and take the square root. So let's do that. So root 2 over 1 minus u squared is going to be equal to 1 over the square root of the sine of x times the cosine of x. And so we've taken care, we've solved for what the denominator is with our u sub. Oh, when we took the square root, we need to take the square root down there as well. So let's substitute that in and then solve. So we're going to get, I'm going to pull the root 2 out. And then we're going to get 1 over the square root of 1 minus u squared du. So this one's going to be trig sub as well. It's not going to be secant though, is it? I think this one is going to be, yeah, okay. So on this one, our u sub is going to be, or for this one, let's do the trig sub. Let's do the trig sub down here. So the u is going to be equal to the sine of theta, because we're kind of thinking cosine. Yeah. And so the du is going to be equal to the cosine of theta d theta. So let's do the u sub in here. So we've got the integral of, let's cosine of theta over the square root of 1 minus sine theta squared. And that's also equal to the cosine squared of theta, the 1 minus the sine squared of theta, d theta. So here, and then we take the square root, and so we're going to get the integral of the cosine of theta over the cosine of theta d theta. So here, 1 minus the sine squared of theta, that's going to be also equal to the cosine squared of theta. And so we take the square root of the cosine of theta, and so we just get cosine squared of theta, and so we just get cosine over cosine, root 2. And so right down here, we're going to get the integral of 1 d theta root 2. So now let's do our triangle to figure out what our shenanigans was. So we're just integrating, yeah, we will need to figure out in a second. So we're gonna integrate it, so let's bring this over here. So we get root 2 times theta plus c, but we need to get theta in terms of u, and then so we can get in terms of x. So theta is going to be equal to the arc sine of u. If you take the arc sine of u, then you're going to get theta. So that's going to be equal to that. So we're going to do root 2 and then arc sine of u plus c, but u is all the way back up there, so let's plug that in as well. So 2 arc sine of u was the sine of x minus the cosine of x plus c. And so that is the second part of our formula that we're going to add to this one in just a second. So the trick that you kind of learn once you do this integral is that sometimes when it's like you set up the u sub, so the derivative is the numerator. And that's kind of the trick that I found applies to other integrals. Like, oh, learning one integral isn't that helpful for like integrating stuff. So you want to kind of like pull things back and maybe make them more abstract. Like, what are some things that can help you? I think the creating a du that takes care of the numerator is something that's helped me solve other integrals. So that's something to think about when doing this. So in the next part, let's just add up these two, and then we'll get our answer for, we got to add up 2 and then divide it by 2, but that'll be in the next part. Okay, so we know what this is equal to, we know what this is equal to, and we've got them both down here. So basically for this step, we are going to be basically adding them together, and then we're going to divide it by 2, and that'll be our answer for the square root of the tangent of x. So let's just do that now. So we've got root 2 arc sine of the sine x minus the cosine of x plus, let's just plus, yeah, let's do that, root 2 times the ln of negative sine of x minus the cosine of x plus the square root the sine of 2x plus c, of course. And that's going to be equal to 2 that's going to be equal to 2 times. So if we divide each term by 2, that is going to be our final answer of what the square root of the tangent of x is going to be equal to. Yeah, really fun problem. Really messy at some parts, but once you kind of get the idea, it becomes really cool and it can actually help you learn other integrals. So yeah, that's it for that one.